Welcome to Trusted Data Summit 2025. We at Datagaps are thrilled you're here.
Hello and welcome to Datagaps Trusted Data Summit. My name is Dinesh Chandrasekhar. I'm the Chief Analyst at Stratola, a business strategy consulting and industry analyst firm. I'm super excited to be here at this conference talking to you about one of the most hot and pressing topics. It's not just agentic AI, but how do you build trust in agentic AI through data-centric validation? I think this is a topic that everybody will resonate well today, given that we are still on the wall when it comes to trusting AI agents. So this talk will explore how do we get over that wall, gain more trust in deploying AI agents, and be more prepared for the future. So with that said, I welcome you to this keynote talk, and let's get started. As I said, my name is Dinesh Chandrasekhar. I've been in the industry for a little over 32 years, done all types of wearing multiple hats, technologist, marketer, industry analyst, and so on. I have worked in a variety of different companies, a lot of which you might really recognize, listed out there on the slide. I run a couple of podcasts. If you are not familiar with Stratola Spectrum, I urge you to go look it up on YouTube and subscribe to it. I have a lot of conversations with data and AI leaders around topics that, like the one that we are just about to talk about. So with that said, let's talk about the problem. Analysts like me and others have been saying that agentic AI is on the rise. I mean, for crying out loud, we have heard that 2025 is the year of agents from like multiple sources. Everybody has been saying that. We are almost at the end of 2025. And if you ask me how much of AI agent adoption has happened, that's where, again, we go back to the numbers that have been reported by various sources. And we see that only like 15% of IT leaders are even looking at piloting and deploying fully autonomous agents and so forth. And again, reported by reputed analysts. But the one common theme that you see across reports like what you see on the screen, whether it be from Capgemini or from Gartner or from others, is that trust is a major factor that is deterring AI agents from getting deployed into the enterprises. So let's talk about how do we gain that trust? How do we gain get over the wall, as I said, with the AI agents, and make sure that we can deploy trustable, trustworthy AI agents that can work seamlessly with our enterprise data, and we can look forward to a more automated and autonomous future. The key question to ask is, can you tell me exactly what data our AI agents accessed yesterday? And it's not just about whether it accessed a specific data, but you also want to ask, what logic did it apply? Whether the output it produced is actually verified and accurate and so forth. These are the types of questions that I guarantee you a lot of the IT leaders that are talking about agents and deploying agents and all that cannot answer. And that's exactly the problem that we want to talk about today, because there is a trust crisis that is brewing between agent deployment, which is happening at a speed that we have never seen before. I mean, for crying out loud, we have come through data pipeline, observability, and establishment over the last couple of decades. And the kind of pace at which we did that versus the kind of pace at which we are deploying agents is like night and day, right? The speed is unimaginable. We are like really trigger happy when it comes to like deploying agents or like, adopting agent technologies and all that. Pushing it to production is a different story, but even adopting it and like putting it for like, different types of use cases, we see that we are pretty excited about it, and we are going at a speed which is like unmanageable. But the real question is, can we trust those agents to handle enterprise data? Can we trust an agent to make those decisions on our behalf autonomously? And that's the key question, which is causing this gap, as I said, the trust crisis. So there is no denying that agentic AI is moving from demos to production decisions soon, if not now, in the next few months or next year, maybe, right? So definitely, if 2025 wasn't the year, 2026 maybe is the year for the AI agents. What that means is now agents are performing autonomous database queries, real-time analytics, and automated reporting, and so forth. That means they are handling enterprise data, they're making those decisions, and they are like working, seamlessly with our enterprise data on a day-to-day basis. But as I said, the gap between the deployment velocity and the validation rigor that is needed is widening. And that just indicates that the trust crisis is just waiting to happen. So is AI the problem? Because we keep saying we cannot trust AI agents, so forth. I'm not trying to like paint a doom and gloom picture here, but we all have heard about like AI hallucinations and so forth. Is that the one that is causing the problem? And I want to like make sure that you understand that that exactly is not the only problem. The bigger problem is actually a data observability problem, and it's solvable. And that's what we're going to talk about today. Let's talk about understanding the agent data interface. This is exactly where things go wrong. When an AI agent interacts with your data, it goes through four critical stages. I call this the Agent Data Lifecycle, and every stage is a potential point of failure. And right now, most organizations are breezing through, flying blind through all four of them. Stage one is data access. This is where agent queries your systems. Traditional data systems have like predictable access patterns. Your ETL runs at like 2 a.m., queries these 5 tables, joins them in a way. You can validate that, you can monitor that. AI agents don't work that way, right? They generate queries dynamically based on natural language requests. You don't control what they ask for. You don't even know what they're going to ask for until they actually ask it. And here's what's wrong. An agent needs to analyze, let's say, customer behavior. It's supposed to query your production customer table, but somewhere in its reasoning, it decides to query the staging table instead, or it hits yesterday's snapshot, or it accesses data from an incomplete overnight load. But the worst part is not even that. The worst part is that the agent doesn't know that it made a mistake. It confidently proceeds with incorrect data. The blind spot here is that traditional data quality tools check data at rest, and they always validate your warehouse after the load's complete and all that. But agents access not only that, but also data in flight, dynamically, unpredictably. So your existing monitoring quite doesn't see it. Data interpretation, stage two. This is where now that the agent has accessed the right data, now it has to understand what the data means, right? So this is the semantic part of it, the semantic problem. And it's more challenging than you think. So let's say your agent queries a column called active customer. Finance defines active customer as anyone with an outstanding contract. Now, sales defines it as anyone with a contract or anyone in active negotiations. Marketing defines it as anyone who's engaged with your brand in the last 90 days. Same column name, three completely different business definitions. So your agent doesn't know which definition to use. If it picks one, or worse, makes up its own interpretation, and now your metrics are practically nonsense. So we have spent like years building data warehouses. We have never enforced semantic consistency because we have always assumed that humans would know the difference, right? Humans usually do, but agents don't. Here's another example. A retail client had an agent calculating average deal size, right? The agent divided total revenue by total customers, except the correct calculation was total revenue by closed customers and not all customers. So the agent's average deal size was 40% lower than reality because it included thousands of people or prospects who never bought anything. So the result is that the sales team thought the deal sizes were shrinking. They started offering bigger discounts, and revenue actually declined because they were actually solving a problem that didn't exist in the first place. So the gap is that we have built semantic layers for human analysts, business glossaries, data dictionaries, documentation, and so forth. But agents need programmatically enforceable semantic contracts. And they need to know at query time what active customer means in this context for use in this particular domain. Stage three, data transformation. Now, we get to the really dangerous part here. The agent has accessed data, it has interpreted what it means. Now it's going to transform it, aggregate it, calculate metrics, apply business logic, and so forth. So this is where traditional testing completely breaks down because when you write SQL, you can code review it. When you build a DBT model, it's in version control. When you build or create a Tableau calculation, you can audit the formula. But when an LLM reasons over your data, you can't Git review an LLM's logic. The agent makes calculations. You didn't explicitly program. It reasons, it infers, it applies what it learned from training data to your specific business context. So here's another example, right? An e-commerce company had an agent forecasting inventory needs. The agent was supposed to calculate 30-day average sales velocity for each product. They discovered 3 months in that the agent was calculating a rolling 30-day average, but it was excluding weekends because it had learned from training data that business metrics often exclude non-business days. But except that this was an e-commerce business, right? So which means weekend sales were 40% of revenue. The agent had systematically under forecast inventory for their highest volume sales days. This is the kind of invisibility problem that we are talking about here. It's very real. You can't trace agent reasoning the way you trace a SQL execution plan. And the agent made a decision, a reasonable decision, based on its training data, but it was wrong for this context, right? Finally, stage 4, data presentation. The final stage is output. The agent has done its work. Now it's presenting the results to its users. What gets shown? What gets filtered? How is it formatted? This is where hallucinations become dangerous. AI agents are confident. They don't say, I think, maybe, based on incomplete data and all that. They present outputs with the same authority, whether they are 99% certain or like making educated guesses. And here's a scenario I've seen multiple times, you've seen multiple times as well, where let's say an agent is asked to show top 10 products by revenue. The agent queries the database and finds only like, let's say 7 products that have complete revenue data. The others are missing, other 3, right, are missing data due to maybe a sync issue or something like that. Maybe replication didn't happen on time or whatever. What does the agent do? It shows the 7 products and it titles the output as top 10 products. So users see top 10 and assume that it's complete, right? And they make decisions based on incomplete data and they don't even know it's incomplete. The other thing to consider is PII exposure. So an agent summarizing customer complaints might might include personally identifiable information, PII, or PHI even in healthcare organizations in its output. A human analyst would catch it, right? But an agent might not. The trust erosion here is cumulative. One confidently wrong answer, and users start questioning everything, right? That the agent is telling them, and rightfully so, because you need to like question that. You no longer can trust that kind of data leakage or security issue happening, data security issue happening. Now let's talk about the meta problem, which is non-determinism. This is what makes it exponentially harder. Agents are non-deterministic, which means the same input can produce different outputs. Run the same query twice and you get like 2 different answers. Not because the data changed, because the agent's reasoning changed. Traditional software testing assumes deterministic behavior. You write a unit test, input X always produces output Y. And if it doesn't, the test fails. That doesn't work with AI agents. They are probabilistic, they are drift, they learn, they evolve. And this means that you can't just test agents before deployment and assume that they'll behave the same way in production. You need continuous validation, you need continuous monitoring, you need continuous verification. And this is the paradigm shift that we are talking about. We are not testing software anymore. We are observing intelligence, and that requires completely different infrastructure. Which brings us to solutions. The Agentic Data Observability Framework. This is what I've seen work across organizations in the last couple of years that have tried to move agentic AI from like pilot to production. Not in sandboxes, not in demos, but actually in systems handling real business decisions, right? What they built, I'm going to share that with you. It's like a systematic framework for agentic data observability. So it's not quite theory, but it's also like production patterns. And I'm going to like talk to you about some of the implementation approaches that might work for you as well. Again, your mileage may vary based on your specific needs and implementations. But what I want to tell you is that this is a framework that has like 5 pillars, and each pillar addresses one of the failure modes that we just discussed. Together, they create a comprehensive trust infrastructure for AI agents. So let's go through them. input traceability, semantic validation, logic auditability, output verification, and behavioral monitoring. These are the five pillars as a part of this framework, and we're going to go into each one of those. So let's talk about input traceability, the first pillar, right? Know what your agent touched. If you can't reconstruct exactly what an agent accessed for any given output, you can't debug failures. You can't validate correctness. You can't maintain the compliance of the whatever you're working with. The requirement is straightforward: complete traceability of agent data access. And what that means is that every time an agent queries a database, the query is logged, not just the SQL text, but the full context of it, timestamp with millisecond precision, the data sources that were accessed, tables, columns, maybe even specific rows if possible, the resulting set size, data freshness, which is again something that a lot of people don't realize as to how important that is, because you want to know how when was the last time this data was updated, because you could be working off of a stale data set, and that could be causing some issues as well. Data quality scores, were there any known quality issues with this particular data? And then who was the user that invoked it, the agent's identity, and so forth. This creates an entire audit trail, right? So data lineage, as they say, is what we are trying to create here, where we know that this is not just for compliance, but also for operational debugging, right? I'll give you an example again. Risk analyst at a financial services firm, maybe they're using their agent-powered analytics platform, right? The risk analyst now questioning one of the agent's portfolio risk scores. The score seems to be too low for a high volatility portfolio. So because they, implemented input traceability, let's assume that, they can now reconstruct this entire data access path in under 60 seconds. They discover that the agent is querying an older version of the volatility index, a table that should have been deprecated, but still was accessible, right? So this kind of clarity gives them the immediate fix and say, okay, let's fix this immediately. More importantly, let's add a validation rule that agents can't use deprecated tables. So without input traceability, that bug would have gone unnoticed until it actually caused a real portfolio decision error. How do you implement this? The key is zero overhead instrumentation, right? So you can't slow down agents with heavy logging. Use asynchronous capture, stream to a separate observability platform, data lake, whatever, and index it for faster retrieval. And here's the critical integration point. Your existing data lineage tools need to also extend to agents. If you track lineage for ETL, you should track lineage for agent queries as well. And so the good news is that the infrastructure exists. You're probably already doing this for your pipelines. You just need to extend it to cover agents. Pillar 2, semantic validation. Make sure your agents actually understand what your data means. We spoke about this problem just now, and it's not about just what your schema says, right? Syntactically correct queries can be semantically catastrophic, right? The requirement is that agents must prove that they actually understand the business context before they actually access the data. How do you enforce this? First, agents can't query raw tables directly. They must go through a semantic layer. Whatever you're using, DBT metrics, universal semantic layer, your own metadata framework, the semantic layer enforces the decisions or the definitions. And so when an agent is wanting to know active customers, it must first specify which definition: finances definition, sales definition, marketing's definition. Second, you must implement data contracts. These are programmatic agreements that specify not just the schema, that this column is an integer, but actual business logic, which says this column represents customers with contracts signed in the last 90 days, excluding trials, and it's also in USD, right? So this kind of specification, this exact description about the business logic, make sure that there is an enforceable data contract here about that particular column. So in a healthcare organization, when an AI agent within an AI agent powered patient analytics system, let's say it queries patient count, the semantic layer must first intercept the query and ask which patient count. Is it total registered patients, active patients, patients seen in this fiscal year, patients with current treatment plans? The agent cannot proceed without clarifying the semantic intent. And I know this seems like a little bit of a friction, but it's actually essential friction. It forces precision, it prevents ambiguity. And once you enforce semantic validation, consistency will improve dramatically. The technical implementation is contract first architecture, right? So data products must publish contracts, explicit specifications about what they contain, what their data actually means. Agents must declare which contract they're using before they actually access the data. And the enforcement mechanism is that your data quality platform validates at query time that the agent's semantic understanding matches the data contract. And if there is a mismatch, the query is rejected, the agent must clarify. Pillar three, logic auditability. The third pillar tackles the black box problem, which is making agent reasoning transparent. If you can't see the logic chain from raw data to agent conclusion, you are flying blind. The requirement is that full auditability of agent reasoning. So here's how we achieve this. First, reasoning trace logging. When an agent performs calculations, these calculations are then captured in structured logs, not just the final answer, but the intermediate steps. What calculations were performed, what business roles or rules, were applied, what assumptions were made, what transformations occurred. Second, shadow validation. You run deterministic calculations in parallel to agent reasoning. If the agent calculates Q3 gross margin, let's say, you also calculate using a tested validated formula. And if there's a divergence, if there is some kind of a discrepancy, you flag it immediately. Third, explain more. You force the agents to document their work in human auditable format. So a quick example would be a retail company implementing logic auditability for their agent-based inventory risk scoring. The agent would analyze, let's say, inventory levels, sales velocity, lead times, dozens of other factors to produce a risk score. Initially, this would be a black box, without like logic auditability, right? So the agent, let's say, if it says the product risk has a score of 6.9 and nobody could have verified why, implementing logic auditability would actually make sure that the agent's reasoning trace would show that it considered, like, I don't know, 36 different factors. It weighted them according to historical correlation with stockouts and what is the exact formula it used. Here's the data it actually input into the formula and the intermediate calculation results and so forth. So every single thing is like documented for you to audit. And so when business is questioned about this particular risk score, they could fully audit the logic. And the payoff is that the logic trace will reveal that the agent was maybe double counting certain supplier reliability metrics, and it was inflating risk scores or for specific products from those reliable suppliers and so forth. And this could change it. This is the way to fix the problem once they audit the logic to correct the agent's reasoning. So without logic auditability, that error would have persisted indefinitely, and no easy way to catch it. The critical success factor is structured logging, right? So not just text explanations, but structured data that downstream tools can validate. You want to be able to programmatically compare agent logic against good known business rules. And if the agent's calculation diverges from the approved formula, you can catch it automatically. Pillar 4. The fourth pillar is your last line of defense. Validate these agent outputs before they actually reach the users. So the requirement is that prove that the agent outputs are accurate, complete, safe to share. And this is where reconciliation becomes super critical. How do you verify agent outputs? First, you can start with automated reconciliation, right? So you can compare agents outputs against known good sources. The agent says Q3 revenue is so and so. You reconcile that against your source of truth, financial system, and if there is some kind of a variance, you investigate before the output reaches the users. Second is confidence scoring. The agent must declare its confidence level for every output. High confidence outputs can be delivered automatically. Low confidence output triggers automatically, let's say, a human in the loop. Third, completeness checks, right? So this is where you can validate that result sets are actually complete. If an agent is supposed to show 10 items but shows only 7, that's flagged automatically, right? And that's a problem that we spoke about just now. And the last thing is maybe PII and compliance scanning. every output that is screened before delivery. That makes sure that agents can't leak like sensitive data. So the most critical success factor is automation, right? Manual spot checks don't work at scale. It's very challenging to do so. So you need continuous automated validation. And here's where your existing data quality infrastructure becomes invaluable, right? The same reconciliation engines you use for ETL validation can also validate agent outputs. So you're not really building it from scratch, but you're extending proven patterns to a new use case. Last pillar is behavioral monitoring. The fifth and final pillar, right? This addresses that non-determinism problem that we spoke about. Detect when an agent behavior changes over time. The requirement is continuous monitoring for agent drift. Non-deterministic systems change. Yesterday's correct agent might be today's liability, right? So you need to know when that happens. How do you monitor for drift? The first thing is to like establish a baseline. When an agent is working correctly, you capture its behavior signature and make sure that that is documented as a baseline. So you document like what data sources does it typically query, what is the distribution of its outputs, what calculation patterns does it use, how long the queries take, and all that. That baseline becomes your reference point. Second is anomaly detection. You continuously monitor for deviations from the baseline. Is the agent suddenly querying different tables, or output distributions shifting, or query patterns changing? Is performance degrading? All those, right? The third is version control for agent behavior. When you update models, change prompts, or modify configurations, if the behavior changes, you know what caused it. So that could be another thing to consider. Fourth is like regression testing, right? You continuously rerun historical scenarios. The agent should produce consistent results for the same inputs over time. And so the real success factor here is real-time alerting. You can't wait for monthly reviews. Behavioral drift must trigger immediate investigation. And this again leverages existing infrastructure. If you monitor for data drift, distribution changes, schema evolution, quality degradation, and so forth, you can extend those same techniques to monitor agent behavior drift as well. Okay, so we covered the what and the why. Let's talk about the how. How do you actually build this infrastructure? What is the technical stack? I'm going to give you like a little practical architecture thing that you can put to use. So we're going to talk about something called as the Observable Agent Stack. So it has 4 layers, and think of it as like a vertical integration from agent instrumentation up through like executive dashboards, right? Layer 1 is the instrumentation layer. This is where it starts. Every agent needs telemetry built in. You need agent SDKs that automatically log activity, every data access, every reasoning step, every output generated, captured by default and not as an afterthought. So the emerging standard here is OpenTelemetry. I mean, OTel has been around for ages, but the adoption is like picking up slowly. Now this needs to be extended for agents as well. OpenTelemetry already provides observability for distributed systems. Now it needs to cover agentic systems as well. The key is structured logging, right? Not just text dumps, but JSON schemas for like agent activity, agent ID, version, user context, query text parameters, data sources, reasoning traces, outputs generated, and so on and so forth. This telemetry data will be streamed into your observability platform in real time. Layer 2 is the validation layer, and this is where you enforce the contracts in real time, right? So before an agent queries the data, the validation layer kicks in. Does this agent have the permissions to access the data? Does the agent understand the semantic contract? Is the data fresh enough for this use case? Are there any known quality issues with this data and so forth? So the validation layer is your control plane. Agents can't bypass it, and all data access has to go through like governed pathways. The technical implementation is usually like middleware, right? So sitting between agents and data sources, intercepting queries, applying policy, logging everything, and so forth. So your semantic layer becomes part of this control plane. Agents must query through the semantic layer, not directly raw tables, as I mentioned earlier. The reconciliation layer, which is layer 3, is where you verify that these outputs against the grounded truth, right? So every agent will output triggered, or every agent output will trigger automated comparison, right? Agent calculated metrics versus source system metrics, agent aggregations versus known good aggregations, and so forth. So if discrepancies emerge, they are flagged immediately. Low severity mismatches go to a review queue, and high severity mismatches, maybe blocked output delivery and so forth. So the critical innovation here is feedback loops. When you discover an agent error through reconciliation, that error becomes training data. The agent learns what correct looks like for your specific business context. So this is where your existing ETL validation and data quality monitoring tools become kind of like the backbone. You're already reconciling data between systems. You just need to extend that to reconcile agent outputs as well. Last layer is the observability platform, and this is where everything comes together, right? So unified view of agent health and all that. So your observability platform aggregates telemetry from all agents and provides real-time dashboards, which can show like how many agents are running, what's their accuracy rate, what errors are concentrated, and all that. And alert management could be part of it. Audit trails, analytics, which include like trends, patterns, anomalies, and all that. So the user interface here is very critical, right? Data stewards need dashboards that show agent accuracy rates by type, by use case, by domain, query patterns, which are like what data or agents accessing most frequently, drift detection, which agents are behaving differently than baseline, compliance status, or agents respecting governance policies, and so forth. Executives will also have like business level dashboards, which will indicate like what percent of like agent outputs are validated, what's our trust score, where is our highest risk deployment, and so forth. So this kind of is the framework or the stack, which as I called as observable agent stack, which you can implement at these different levels in order to control or address the challenges that we spoke about earlier. So this is the how part of it. The other thing that I want to talk about is the DevOps integration, right? So all of this needs to integrate with your CI/CD pipelines. Agents are code, they should be deployed like code with gates and guardrails and so forth. So when an agent or before an agent reaches production, right? You need to have validation gates. Does the agent meet like accuracy thresholds and staging, safety checks? Does it respect like data contracts, regression testing to see if it performs as well as the previous version and so forth? And deploy with observability, right? So do some canary deployments, roll out like changes to 5% of the users, monitor for issues, do some automated rollbacks if accuracy drops down below a certain threshold and so forth, auto revert to the previous version, do some A/B testing, compare new agent behavior with the old one and so forth. So I know this might sound a little complex, but it's just like DevOps principles, right? But we are applying it towards AI, and we know how to do this for microservices, and we are just extending it to agents. So with that said, I want to bring it to a closure here. We spoke about the what, the why, and the how, and so forth. Now I want to talk about the road ahead, right? So what lies ahead for us? Where is this headed? So a few predictions. I'm an analyst, so I got to do this. The first thing is that agentic data observability becomes table stakes for mature AI organizations, right? So this is kind of going to be that. Right now, this is like cutting edge. 2 years from now, this will be expected. Investors will ask about it. Regulators will require this for certain industries. Customers will demand it as a part of like vendor contracts and so forth. Organizations that build this infrastructure now will have a significant competitive advantage. They'll be able to deploy agents faster and scale them more aggressively because they have solved the trust problem. Second thing is that we are going to see a convergence of data ops, ML ops, and AI ops or agent ops, right? So not AI ops, that's a different term. Agent ops. This is a kind of a term that is coming to the market of late, and let's call this a unified observability pipeline, right? So the silos between data engineering, machine learning, and agent operations are kind of like artificial at this point. The problems are interconnected. The solutions need to be integrated. So the platforms that will win are the ones that will provide the end-to-end observability from raw data ingestion to agent reasoning to the actual business outcomes. Third, the market will evolve rapidly, right? Every major data platform, observability platform will add native agent observability capabilities. It'll be a checkbox feature, right, within the next 12 to 18 months, if not even sooner. But early movers definitely have the advantage. You can shape these tools to your needs rather than adapting to vendor roadmaps. That's the most important thing. Let's talk about the competitive advantage this offers, right? This is why exactly it matters so strategically that in the near future, AI capability will be commoditized, if not already, right? I mean, we are seeing this like so much happening around us that every organization will have access to the most powerful models, whether it be GPT-6, 7, Llama 5, Claude 4, whatever comes next. It'll be available to everybody. And so the differentiator won't be AI, it'll be trust. Organizations that can prove that their agents are trustworthy, that can show audit trails, that can demonstrate accuracy, that can explain the reasoning, are the ones that will win the deals, that will attract the customers, that will command premium pricing. Trust becomes the moat. And there's the compounding effect, right? So observable agents get better over time. Every error that you catch now feeds the learning loop. Every validation that you perform now will improve the system. Agents without observability stay risky indefinitely. Agents with observability they become more trustworthy with every day of operation. So, big question. What should you do Monday morning, right? After this conference, you all collect your notes and you go back. What are the things that you should do? First thing, audit your current state. What agents are touching production systems right now, in production data particularly? Can you address or trace their data access? Do you know what logic they are applying? Can you verify their outputs? If your answer to any of these questions is no, you have work to do, right? Second, start with the instrumentation. Pick one agent, your most important, most risky agent, and then start instrumenting it completely. Log everything, capture every query, every reasoning that it does, every output that it produces, then analyze the patterns. You'll be shocked by what you discover, and agents do unexpected things. The third thing is that you want to establish baselines. We spoke about this. Define what correct agent behavior looks like for your organization, and then what accuracy rate is acceptable for yours. Because we are not going to get 100% accuracy anytime soon. So we want to define those as well. And then what query patterns are normal? What drift is tolerable for your organization? So those are things that you might want to determine as well. Because you can't detect anomalies until you define what normal is. Fourth thing, build validation gates. No agent output should reach users without basic verification. Start simple. Reconcile agent calculations against source systems. Check for PII exposure. Flag low confidence outputs for review. And then the fifth thing is partner. Partner strategically. Work with platforms and vendors that understand data validation at scale. Don't try to build everything out from scratch, because you want to leverage existing infrastructure where you can, but own the integration, own the architecture. And this is kind of almost like too important to outsource completely. The winners will be the ones who solve observability first, data observability, agentic data observability. You have a choice, right? So path one is where you can deploy agents without observability, move fast, hope for the best, deal with the trust crisis reactively whenever it happens, right? It'll happen, but whenever it happens. Path two is where you build observability first, move deliberately, you earn trust systematically, and then you scale with confidence. The responsible choice is obvious, but I want to leave you with this one final thought. If you can't observe how your agents handle data, you can't trust what they tell your business. So make sure you get that kind of as a takeaway. The infrastructure to build that trust exists. I hope you use that framework I shared and adopt it within your own enterprises. Wishing you a fantastic conference and an amazing day. Thank you so much for joining my keynote today.
For further questions, feel free to reach contact@datagaps.com. Request a free demo, scan the QR code below. Thank you.